Hello everyone, this is Kiran and today we are going to learn about test case designing techniques which are equivalence partitioning and boundary value analysis. Let's move forward with the session. Here we go. So what is test case design techniques? So there are various techniques which we need to apply to make sure that when we are writing the test cases, we are not missing out test cases. So for testing any particular scenarios, we have to make sure that we are testing everything and we are not missing on any aspect of that particular scenario. So for understanding that, we need to know and apply these techniques. So there are various techniques which can be used like equivalence partitioning, boundary value analysis, decision table testing, state transition diagram, use case testing, error guessing and so on. Today we are going to learn only about equivalence partitioning and boundary value analysis. So let's move forward and see what they are. Now, equivalence partitioning is a black box testing technique which we are applying to check that all the data set has been applied and the scenario has been tested well. This technique and equivalence partitioning is based on a logic wherein we create valid and invalid partitions for a particular scenario. And then we choose one data set from each partition. All the partitions will choose one data set. So we'll take an example and understand this. And why do we choose one data from each partition? We'll understand that too. So we have to understand we are applying these testing techniques on our test case designing phase so that we are not missing out test cases. We should know that all the test cases has to be written. So for that we have to apply all permutations and combinations of the data sets which should be applied for testing. So for that we are applying this. So equivalence partitioning, we'll take a quick example here. So let's take an airline reservation system and it says that if you have the book ticket number 1 to 10, you get a valid ticket, and if you're getting something between 11 to 99, you have an invalid ticket. So there is a partition which got created, valid and invalid. Now you have to now understand how do you do the testing in equivalence partitioning. Okay. Let me give you a diagram to make this easy. Now, we have seen that we have got two partitions, one is valid and one is invalid. So we'll create both partitions. This is the valid partition which is from 1 to 10 and 11 to 99 are invalid partitions. Your ticket is invalid if you have got between 11 to 29. So the equivalence partitioning logic says that if you choose data between 1 and 10, let's say 3 you chose, and if you choose another data from the invalid partition which is let's say 14, and you do the testing, your testing is complete. But you have to make sure that you have created all the partitions. So there's no partition which is left to be created. Once you have created all the partitions, you have to choose one data set from each partition. The logic says that if you do the testing using one data from one partition, all other data sets will also be behaving in the same manner as that particular one data is behaving. Let's say you chose 3 and 3 is being accepted as a valid entry and you got a correct ticket in the airline reservation system. So 1, 2, 4, 5, 6, 7, 8, 9 and 10 will also behave in the same manner. Similarly, if you chose 14 and it got rejected because in the airline reservation system because it was from an invalid partition and your booking ID has to be rejected in that case. So all data set which is 11, 12, 13 and 15 till 99, all these data will also behave in the same manner as 14 is behaving. So that is equivalence partitioning. You have to create valid and invalid partitions for your scenario. You have to choose one data from each partition. You have to apply that data and do the testing, and you can say that yes, your testing is done. That is, if one data is behaving in a particular manner from one partition, all other data will also behave in the same manner from that particular partition. That is equivalence partitioning. So we'll quickly go back to the PPT. Let me also give you an example so that you understand this better. Okay, let's say you are allowed to fill in a form if you belong to a particular age group, which is 18 to 35. So only if you belong to 18 to 35, you'll be allowed to fill in the form. And rest, you will not be allowed to fill in the form. So this 18 to 35 is a valid partition. 36 and above is an invalid partition. You'll not be allowed to fill in a form for a college or something maybe. And if you're below 17, you'll again not be allowed to fill in the form. So I created all partitions which are possible. 0 to 17 is an invalid partition, 18 to 35 is a valid partition, 36 and above is an invalid partition. Now the equivalence partitioning logic says that you have to choose one data set from each partition. So I chose 2 from this partition, which is an invalid one, 0 to 17. I chose 19 from the valid partition, and I chose 100 from the invalid partition because there is no upper limit, so you can choose any data in the age. So I chose 100. Now if I do the testing using these 3 data, my entire scenario is tested well and I don't need to apply all other data sets and do the testing. So that is equivalence partitioning. Going back to the PPT, what is boundary value analysis now? So it is a variant of equivalence partitioning wherein instead of choosing data from within the partition, you do the testing using all the boundary values. So what we did in the equivalence partitioning, we chose data set from within the partition. Here it's the same, similar to the equivalence partitioning logic, but here you do the testing using all the boundary values. So boundary value analysis say the same thing, that if you do the testing using all the boundary values of all the partitions, your testing can be said as complete. So if we see our diagram here, so in the equivalence partitioning, you were using data like 2, 19 and 100. But if you are using boundary value analysis technique, you will have to choose data sets which is 0, 17, 18, 35 and 36. So if you do the testing using all these boundary values, you can say that yes, your testing is complete. It is very similar to equivalence partitioning, but yes, the data sets which you are choosing is different and the logic is different, that you have to do the testing using all the boundary values. Going back to the PPT, we'll come up with a question now. So let's say in an examination, a candidate has to score a minimum of 24 marks to pass, and what he can score maximum is 40. So there is valid and invalid partitions which you got already, like 24 to 40 is the valid partition, 41 and above is invalid because a person cannot get above 40, and 23 and below is again invalid because if it is he's getting below 24, below 24, yes, he is anyways failing. So you have to identify the valid equivalence values only. The questions can be tricky in these kind of sections because you have to read properly, that you have to find out all the equivalence values, or you have to find valid equivalence values, or you have to find invalid equivalence values. So here the question is being asked about only choosing the valid equivalence values. So we have A, B, C and D. So 22 is anyways gone because it's falling in the invalid partition, which is below 24. 21, option number B, which contains 21, is again opted out because it is again falling below 24. Option number C contains 29, 30 and 31, which all are above 24 and below 40. So C is the answer. We'll check D also. D has 0 anyways, which is in the invalid partition. So it will also be not accepted. So our answer is C here because the question was to choose all the valid equivalence values only. So all the valid values are lying only in the C option. So our answer is C. We'll take one more question to understand this concept. The switch is switched off once the temperature falls below 18. So 18 and below is off, and then it is turned on when the temperature is more than 21. So 21 and above is on. So there is one more, which is 19 to 20. So 19 and 20 are another partition which is doing nothing. Below 18. So basically below 18 is 17 to below, and 18, 19, 20 and 21 is one partition, and 21 and above, 22 and above is another partition here. So we have created 3 partitions. Now So the question is identify the equivalence values which belong to the same class. That is, all the values should be belonging to the same partition now. Let's see. Option A, 12, 16. Yes, 12 and 16 are in the same partition which is below 18. 22. No, because 22 is in the third partition. Opted out. B, 24. Yes, in the last partition. 27. Yes, in the last partition. 17. So it belongs to the first partition. So this is also not the option. Now 22 and 23, it belongs to the partition 21 and above. 24 also yes, so C is the option. We'll check D also. So 14 and 15, it belongs to the 18 and below partition, but 19, it belongs in the partition which is in between 18 and 21. So it is in between that. So it's also not in the same partition. So we have to read the question properly and then answer. So as per the question, the correct answer is C, that 22, 23 and 24 all are belonging to the same partition. So C is the answer. Let's take another example and see how do we validate boundary value analysis also. So a program validates a numeric field as follows. Values less than 10 are rejected. So 10 and below is invalid partition. Values between 10 and 21 are accepted. Okay, so 9 and below is invalid, 10 to 21 is valid, and values greater than 22 are rejected. Greater than or equal to 22 are rejected. So 22 and above are also invalid. So you have to choose the option which covers most of the boundary values. Now you know now what you have to do in boundary value. You have to choose only the values which lie in the boundaries. So our boundaries contain 9 and below, 10, 21, 22. So we'll see which option has more of these values. First option, 9, 10, 11. So 11 is not in the boundary. So the A option is chucked out. B, 9, 10, 21, 22. So B is the answer here. We'll check C and D also. 10, 11, 11 is anyways not in the boundaries, and D 11 again not in the boundaries. So option is B here, because B contains all the boundary values. So you have to choose only the values which lie in the boundary in case of boundary value analysis. So today we learned about the testing techniques, equivalence partitioning and boundary value analysis. These are the techniques which we use so that we can cover most of the test cases and we can do the testing properly without missing out on any data. The equivalence partitioning techniques say that if you create proper valid and invalid partitions for a scenario and you choose one data from each partition, your testing is complete. It means that if one data set behaves in a particular manner from one partition, all other data sets from the same partition will behave in the same manner. So you have to only choose one data from all the partitions. Boundary value analysis is a variant of equivalence partitioning which believes in the same concept, but you have to only choose the values lying on the boundaries, not the data from between the partitions. So that's all from today. I'll take a leave. We'll learn a lot more about testing in the upcoming sessions. Thank you for now.